Is my screen visible?
Yes, it is visible.
Okay. So, yeah, welcome to the week 11 discussion. I am Udiptya from IIT Madras, and so this week is on the kind of a continuation, yeah, on scientific communication. So, last week we were mostly discussing on scientific writing papers, and then this time it's continuing to PhD thesis and some text stylistics, so some text structure and some common mistakes and all. Then we go for presentations and posters, and also we focus on some writing on some grant proposals. So on PhD thesis, so it's kind of a bigger version of the papers that we have seen, and it has multiple chapters in it, and which all make it a document of around 150 to 300 pages. And so in that it has uh, different chapters, and also it has chapters of introduction, and also the in between chapters, like depending on your study, and also a conclusion. So and like inside that, each chapter will have their own introduction and own conclusion, and also this conclusion of the paper also will have some like future directions, or like how the future ahead. So how the research you have done in this PhD will be can be taken up as a starting point for other researches. So as we know, like being research is kind of a research goes hands in hand. Yeah, we can't do all the research together. So yeah, so that's all like kind of a structure for PhD thesis. And then we have the also we have one element of synopsis, yeah, in the PhD, which is kind of a document of around like less than 10 pages, and which essentially has some principal data, and it is essential for finding examiners for the thesis. So it should be made in such a way that it arouses interest in the examiners, and they essentially agree for reviewing the thesis, the complete thesis. So they kind of act as your peer reviewers for your exam, for your thesis. So that was kind of introduction. So then we go for scientific posters. Essentially, I didn't include scientific presentations because in the last time when we were discussing on art of scientific communication, we discussed the different aspects of like uh, different aspects, as in like what all we have to keep in mind. Keep in mind of the audience, keep in mind of the content, and how it should be designed. So I directly jump to the scientific posters part. So posters is essentially a fantastic way of communicating science in a rapid, concise, and a visual way. And we need to plan the posters, like each whenever we go for some conferences, they will have some their own format. Yeah, so we have to plan our posters accordingly. So you have some a not format, or they will have their this feed to this feed kind of notations, and you have to design your posters accordingly. So that design should be made in such a way that it is easy to digest. Yeah, otherwise and otherwise, because it's a rapid mode, yeah, so you have to make it easily digestible in a way that it is aesthetic. So things should be kind of pleasing to the eye, so you need to construct it in such a way that it is pleasing to the eye. Like so people have different ideas in this. Yeah, people will make so there are some scientific, there are some symmetrical formats. There are some colors that are like kind of fruitful here, and which looks good and appeals and magnetically kind of magnetically interest people, yeah, and keep like bring more people to your posters. That's what it is, like to make it more aesthetic, flowy. So everything has a flow, yeah. So you need to plan it, you need to put the different sections here in a way that it's in a correct flow and people can yeah, that's the whole aim, to make it digestible, easy to read and understand, and within a few minutes. So people should be able to digest it within few minutes, as in, because there are multiple posters and people usually spend a few minutes, 5 to, like the more the max would be 5 minutes, yeah. If it's not making sense in 5 minutes, the person will switch to the next one. So a typical poster has the title. So title is an important aspect of poster. So you have like making it aesthetic and making it pleasing, also making it interesting. The title comes as a play. Yeah, you have to make proper titles, which essentially arouses the interest of the people. So people will not just write like simple uh, simple titles, yeah, like development of water pump for like you just made a pump, yeah, to take water in like up the building, yeah. So like you will just development of water pump for transporting water. So people will write it in such a way that it's like kind of a question: how to transport water from ground to fifth floor? Yeah, kind of like that. So that will kind of arouse the curiosity of the audience, because as humans we all are kind of curious. So you have to like make your curate your titles in a such a way that it attracts the people. Then there's abstract, objectives, your methods, the results and findings that we'll have of the study. Conclusion, kind of the main references, because we can't have more references, so kind of main, at max 3 or 4 maybe. And then the acknowledgement of your funding agencies and all. So that's kind of makes a kind of a typical poster. Okay, so that was kind of for the this week's theoretical discussions, because we just go to the problems and then we will see. So this is the first problem. So this is a problem from that stylistic part of text. So ideally sentences in a thesis should be or should have. So these are multiple correct, yeah. So you all can just write in the options and then we can discuss. Can you also write on the, yeah, on the chat maybe? Then we can like kind of get hold of it and then we can discuss maybe. Others? Okay, no more question, no more answers. So, ideally, a sentence in a thesis should be or should have. So the first option, yeah, the same family of fonts. So, is it correct or like? So, some of
Correct.
yeah. So essentially, all the fonts should be from the same family. Yeah, this is correct. Same font size. Is it correct or not?
Yes.
Why it should be correct?
Headings will be different and the main text will be different.
Yeah, correct. So anything that has more emphasized or will have the headings might have different font sizes. So this will not be correct. So like it will not be ticked. Passive voice.
Not correct.
Yeah. So most of the it is like
Yeah.
emphasize that everything is written in kind of active voice. This one D.
Correct.
This is correct.
Okay. Like what does it mean? Kind of.
Don't write I.
No, sir. Don't. These also wrong. I think.
Hmm.
We should not write like I. मतलब say, gives special emphasis
Always
on
write I.
personal. Like
Hmm.
Should be third person.
I and you. We ignore that type of things.
Okay.
We should write like we and we should involve we.
So it is correct or not?
It is
Be
not
not
I
correct.
think it is.
Be
I
not
think it is correct
Hmm. Why?
correct.
because it is written in first person. Means we write the results or discussion in a way that we carried out the experiment or we got the concentration in so and so range.
Hmm.
It is that. It is that. I mean, it says that.
I think that is third person.
No, no. It's written plural first person. So I think it is correct.
So plural first person means yeah. So it's right. What he was saying, like we, yeah. And the option E. So function names. What is function names? Like sine, cos, and all these things. Function names.
Yeah, it is correct.
Correct. Function name in advance.
He also correct.
Function names, as we taught in the class, it should be written in bold, like
Not
like
It should be
we have variables like x and y, then we have to write.
No, no. It is not like neither in italics nor in bold.
Yeah.
We just write in a normal font the way we write the other sentences in the result or
Yeah.
in a discussion part. So if function name is there, then we write it very normally. It is not italicized or bold.
E is wrong. I'm not saying that function names we should write in italic, but I'm just saying the function name should be written in bold if it is required to give some special emphasis on writing and give importance to that variable particularly.
If I tell like I don't know about the emphasis part or not, but like essentially if you have to like normally write it, you can write it like normal way, like normal without any italicized bold. But yeah, like I don't know like what conditions of emphasis you are talking about, but yeah, special conditions maybe, but yeah, normally it's like normal writing. Okay. So next one, yeah. So the ideal scientific poster should be This is also like same kind of question. So multiple correct.
Can you maximize the screen?
Maximize. Okay.
The screen? Because your font are visible, so the screen is. Oh yeah.
Okay. I don't know.
Okay, now it's little better.
Okay.
No problem.
Okay.
It's gone out of.
Yeah.
Yeah, now it's fine. Yeah, fine.
Yeah. Okay, we have got one answer from Ishan. Others?
Sir, A and B.
Okay. Okay, let the answers flow in, then we can discuss.
B. B and B.
Okay, the first one, yeah, readable from at least 0.5 meters. So comments on this? No comments?
That is correct.
Can you give a half meter?
Huh?
The half meter from the book.
I am not able to hear. Please.
Actually, it is no, it is not correct. It is 1.5 meters actually.
1.5 to 2 meters.
1.5 meters.
Okay. So yeah, so you need to be at least maintain around, like it should be more than 1.5 meters. If it is visible like then it's like kind of ideal poster. So this will not be correct. The B option.
B is correct.
B is correct.
Yeah,
So
24.
yeah,
Actually.
so it should be, everything should be bigger than 20. 20 is kind of the least size that we had. C.
E not correct.
Okay.
Correct.
C is not correct.
Not correct.
Why?
It is correct.
No, it is correct.
Okay.
It's mentioned that sans serif.
Yeah. So just maybe you all can search what is the difference between sans serif
No,
and
it is correct as per our.
yeah. No, just you can search what's the difference between sans serif and only serif. So there's a difference between this, and why they want this sans serif.
Circle is mandatory for the posters, right?
The font I am using is sans serif or serif. Can anybody answer?
For headings actually, for titles and headings actually.
Yeah, like sans serif does mean something actually. Sans serif and only serif.
It is sans hyphen serif.
Yeah, sans hyphen serif. Yeah,
Hmm.
yeah. Like, is this font that I'm using? It is sans serif or only serif?
I think serif is more decorative comparison to sans serif, and we usually avoid more decorative words.
Yeah. Okay. Decorative in a sense. This.
I mean, it is more stylish comparison to the normal text.
Okay. So this one that I am using, I think it's I don't know what it is. This is Calibria. So this is this is actually sans serif. Okay, and if you want the difference, let me, you can see it actually. So I will write something else. I don't know what the other font is, maybe. So we have to write serif. Okay, here we don't have. Anyway, so maybe we can have sans serif versus serif. Yeah. So here you can see the difference. So this is I hope you can see my screen. Yeah.
Yes.
So this is sans serif. Okay. Yeah. I see. So serif fonts. Okay. Yeah. So this one. Yeah. See, sans serif will have this kind of elongations, and sans serif won't have. So sometimes, like, some kind of, I think, visual thing is there. So in a sense, it does typically refer with that. So yeah, that's the difference of sans serif and serif. So this is sans serif, what I'm using. The option D, same font family. Comments on this?
Correct.
True, sir.
Correct. Yeah. Discussion pitch up 10 to 15 minutes.
No, incorrect.
No,
Incorrect.
Not possible.
It's
Not
3
possible.
3 to 4 months.
3 to 4 minutes.
Yeah, not practical in a sense. And graphs and figures more than running text.
Yeah, this is correct.
Yeah. So more emphasis should be on graphs and figures, and you will be explaining it help of that. So that's
Yeah.
what it is. So
B,
I think,
C, D, E,
yeah.
F.
So some of you, I think, have presented, yeah, in posters or some. I think so. Yeah. So any of you have presented in kind of any poster presentation?
So I've
Yes.
done oral presentation.
Oh, nice. Yeah.
Analysis.
Okay. Like in masters or in PhD?
PhD.
Oh, nice.
I have presented in 108 Indian Science Congress. It was held in Nagpur.
Oh, nice.
37, like,
So it was poster or presentation?
Yeah, it was a oral presentation.
Oh, nice. Yeah, oral presentations are like, yeah.
Yes, it was related to my research subject.
Yeah, got it. So yeah, so some of you will basically know it. So this is a poster, kind of example poster, and you have to tell how it is, or is there something wrong, something.
It doesn't appear as a poster, it appears as some advertisement.
Okay, so one point was like you have to make it more interesting. Yeah, maybe it's a way to make it more
With
interesting.
more text, less figures, and
Yes.
Okay,
more data is used.
more text.
Full of text.
Okay,
The background is too dark to read,
background. Yeah,
not readable. From 1.5 meters, it won't be readable.
not readable. Like, yeah, okay.
Font size are not there.
The background, the color background is also very dark.
Background not readable that I have written.
And the the chronology of the poster is actually not correct
How?
because it is arranged sideways. It should be
Use of many colors, like
Yeah. Kind of distracting, yeah?
yeah. The fonts are different fonts have been used.
Different fonts. Okay.
Yeah, some are bold and it's different from fonts. Some are italics, some are
Is it? I don't know. I can't.
in in the heading.
Size of fonts are different, and different fonts are also used.
Okay.
Like
Mm-hmm.
Should the icons be present, sir? I think that also should not be there.
Which one?
The icons which are represented on the top portion of the
This one.
Picture icons.
yes.
But this typically have, like, you will have in your posters, yeah? Like you are going from some institute, you will have your institute, I think.
But downside that one picture icon is there. That is required.
This one?
Yeah,
Yeah.
because seems to be not required kind of.
Yeah. Yeah, true. Kind of not required here. Not required or
The
you don't
title
represent.
also is starting. It's difficult to read. The initial part of this title is very small, and it just increases.
Yeah, true. Not.
Actually, not able to read the references. Seems not done correctly.
Mm-mm-mm.
Not able to read this.
And any other? Alignment maybe?
There are no graphs and no figures as such in the poster. It's entirely text. Yes, I think we have written the first one.
Yeah, no figures maybe, yeah.
No figures.
And then you can also see this width, yeah. Everything is kind of asymmetric, yeah. The text boxes.
Friends is not numbered.
What, not numbered? I didn't get it.
Friends is literature cited.
Okay. Like in a case it may be not, but yeah. Okay.
It's not visible actually. Read the concept. And the background is
Also, sir, text is not cited. When we write any text, then in that case we have to cite that.
Yeah. So references.
So the conclusion also it's very very little. I think it probably it doesn't explain much of the final discussions or results.
I don't know. I have to maybe read more on it, but yeah.
yeah, it is not visible to read
Yeah.
that much. Yeah.
Yeah. And also the colors are like, I don't know, too much distracting.
Yeah, it's too distracted and too text oriented.
Okay. So yeah, maybe we will, if you start staying here, it will be more. Yeah. So these are some of. So this is kind of one
Not at all
example.
well designed.
Yeah, this is kind of one example. Yeah. So. Okay. So we'll move ahead. So. A typical research proposal that we are, so on that part from grant proposal, there is some flow, yeah, in it. So you have to tell which one of them has a correct flow.
Sir, just one question.
Please.
Is there a question of descriptive type in exam? I think this
No, I
is
think.
descriptive. Okay.
Because last time they had the assignments made in descriptive type, but they have fully removed it. So I think the other TAs have informed you, no, about the
Yes.
yeah. So actually,
Yes.
they belong to the same institute as Professor Soumitra, so they have more.
They have informed that
Yeah,
it will be MCQs and
yeah. Like I think
SQ.
the format of
MSQ, same
yeah,
format of our assignments, how
yeah.
it is. Like if we attempt something which is wrong and one is right, so we get a zero. So basically, it is like
Yeah,
that.
it's kind of the
And,
auto
yeah,
checking, I think.
yeah,
So,
MSQs and MCQs in that format,
so
and
yeah,
some
so
and problems will also be there.
problems, the numerical ones, yeah,
Yeah,
numerical types.
numerical ones, and the calculator will be there itself on the screen.
Yeah, so
Manual.
I hope you all will manage with the numericals. Yeah, that's what.
Yes.
Yeah, I am more worried
Screen
about.
that,
But yeah,
yeah, the screen calculator is tedious to use.
yeah. So so from here, the rest of the questions are from Z test and I think hypothesis testing. So you all were telling about discussing some questions. So this week, so I have 3 weeks of classes left. Uh, like this week, so next will be kind of class. The uh, the on week 12, and I have missed week 5 because of the travel, so that I will take. So on that also we can discuss some of the questions. So by that I think so some of topics, yeah, chi-square confidence level, straight line and errors, and calculation of t and z, and propagation of error. So these are some of the topics.
Confidence interval.
Hmm?
Confidence interval.
Yeah, confidence
Values.
interval.
Yeah.
Yeah, so kind of in the Z test we will. So
Yeah.
confidence interval is something that is like flowing in every form of test. So yeah.
Kindly include the box plot also.
Or the box and whisker, yeah.
Got it.
Yes.
Okay.
This answer is C for this.
Okay. So yeah. So yeah, the kind of flow is like we start from the origin. Yeah, the origin of the proposal, and then we go for the review of status both in international and national, and the importance of the project, and then work plan, the methodology, the time, what we call it as so this time thing, this time chart, yeah, you have different objectives, and here the months written like Jan to Jan 23, then Feb 23, and this chart, and it will be like this, and it will be something will be like this, and then it will be like this.
M schedule is also there.
Yeah, what is this chart called?
Gantt chart.
Yeah, correct. Understood. This is Gantt chart. Yeah. So this chart is something that is there common, and I think you will, if you are submitting some reports as in, so that's
Basically,
kind of
planned work
yeah.
versus the timelines
Got it. Yeah.
till the end of the thesis.
So yeah, then you have plan of action and environmental and ethical impact, expertise of your PI. So if you have multiple way, then you have to mention that, and then summary of roles or responsibilities, and key publication, bibliography, and then the other facilities and all will come. So that's always the like typical format. So yeah, then we'll go to some questions on.
Sir, what
So
is
this
final answer for previous question?
yeah, C.
In C, time chart is not given time schedule.
Which one? No, no, just I discussed this one. So it's like it will be flowy. It's not the complete list actually. Just the flow I have asked.
So what this chart known as?
Gantt chart. G-A-N-T, like G-A-N double T. Gantt.
GAN.
So you will see this chart commonly, and also in some of our times in I think if in our institute we have to submit kind of a yearly report or I think 6 monthly report I have to submit. So
Yes.
in that you will have this kind of work plan or time schedule.
I even asked to. This is mapping the timeline, basically, versus
Yeah.
the
Yeah.
planned work.
So you will planned work, and most of the times we do not.
Yeah, we all we don't
And then
follow
we
it.
have to redesign it,
For some
and
experiments we will be
yeah,
repeating, or what we have expected will not happen that way.
yeah, and it goes on like this. So it's the Gantt chart. Yeah. So the rest of the questions are from Z-test, Z-test sampling also, and also testing. Yeah, hypothesis testing. So I thought let's take this as a thing, and then we can discuss the next ones. The box plot also maybe we can discuss now, but yeah, so I have to answer some questions maybe. So let's see, if time permits, we can have some box plot questions also. So every thing is kind of given here. So in some conditions you have to find the mean and all. So here it's everything is given. So I will be back in a minute. You all can keep trying. Just prepare. Okay, so kind of how to solve it. Anybody has like kind of the approach? How are you trying to solve it? Anyone would like to like tell how are they approaching the question? Okay. Any clarification on the question can also be asked. So,
So here, what we have to calculate, find an interval estimate.
find the interval estimate within a confidence level of. So, the thing is, so our pharmacy.
Values are given here.
Hmm?
Almost all the values are given here when we see
Mm-hmm.
to that is n is given,
Yeah.
mean is given,
Mm-hmm.
standard deviation of a population is given.
Yeah. So you have to tell. You have to tell the interval estimate within the so uh, so
1.96.
you have different values of bottles here, yeah. So you have to tell which one of them lie within the 90% range of that mean value of that bell-shaped curve.
So what will mean, like, if we have population mean will remain same, or
N minus 1.
I'm not getting it.
like the sample mean is given.
Mm-hmm.
So here n is greater than 64. That means the sample size is greater than 25. That means
Mm-hmm.
we have to calculate the z value for that.
Yeah, these are all questions of Z. So I have told you that before. So anyway, I have to just.
So Z.
So how will you find the population mean? Because for calculating z, estimated standard error, in that case we have given the standard deviation of population standard deviation we have given.
Mm-hmm. Yeah.
The sample standard deviation we calculate by dividing by square root of n.
Yeah.
So 3 divided by
Roots
6
like
root under root
64.
of
Yeah.
64.
3 square root of 64, yes, 3 by 8.
3 by square root of 64.
Yeah.
3
So
by
maybe yeah. So others are following it or so I think we can start solving it kind of, yeah. So maybe yeah. So we will start with this formula. Yeah.
3, 6.
Using this completely interval formula.
Your voice is kind of coming very muffled. Yeah.
Example, we are using this completely interval formula, that is mean get into this population.
First, we have to find out the standard error. Here.
Sample.
So SC we have got 0.375.
But somehow I didn't hear his question actually. I don't know, his voice was coming too muffled.
Sorry.
Like somebody was asking me or something. I didn't get it.
Mr. Rajiv was asking.
Yeah.
I just said that we have to use this completely interval formula.
Mm-hmm. Yeah. Like like which formula you are referring to? Kind of.
Completely interval.
Okay.
Yeah, I am talking about.
Like what is the formula in a sense?
6.
This is it's mean plus head into population standard deviation divided by number of samples. Maybe that's
Yeah. Like, yeah, maybe, yeah. Yeah, it
20
will
plus
be.
1 is that would be like 6.5 by 8.
Yeah, got
And
it.
according to it very small, the kind of level is available.
Yeah, correct. So maybe we can start here. So here uh, standard error we have to calculate.
Standard error equal to sigma divided by.
Yeah, the sigma is
The sigma is
3.
3 divided by under root of 64, which comes to 0.375.
Okay, maybe we can put it like that also, no issue. We just go ahead.
0.375.
Yeah, this one equal to
Multiple random sample.
so it will be 20
20
minus new
mu divided by 0.27.
yeah. So you can also write it in a sense new equal to so you have to bring the new here, yeah, and then we can try putting the different values of z corresponding to this, and then we can get the interval of like interval around the new, yeah.
So 20 minus
20 plus minus it will be
plus minus 1.4.
yeah, I think this one, yeah, 3 by 8 z.
3 by 8 z.
So now the task will be to put different values of z here, and then checking what's the spread of it.
So 1.68, 1.96 and 2.58.
Yeah, so the z values for 90 is 1.65. Okay, 1.62. This one?
So 1.6, 1.96 and 2.58.
Yeah, 2.58.
Okay. So the first answer will be 20 plus minus 3 by 8 into 1.65 months. What is this value?
0.6.
Huh?
0.6.
0.6. Okay. Maybe another digit. Another digit you haven't calculated?
0.618. 0.618.
So let's put it 0.62, yeah. months, it will be
20.63 and
it will be 19.382
382 or
6
20.62.
months.
Yeah.
The second one, so for everyone, we are just putting the value of z according to the different conditions. Yeah, I think everyone is following it.
So second one I think is 0.735. 20 plus or minus 7.735.
Okay, 3 by 8 into 1.96. Yeah, what is the value coming?
0.735.
0.735. Okay, let's put it 7 for maybe.
Sir, for 90%, what is the value of jet?
1.62.
Okay. Actually, you have written, I think, 1.65.
Where? Okay.
Yes, sir. Yeah, in first 20 plus or minus 3 by.
It is 1.62.
Okay.
And for second, it will come 19.26 to 20.75.
Plus 220.70.
So at 99 it is 0.967 plus or minus 0.920 plus or minus 0.967.
What was the value?
0.967.
0.96.
Okay.
Sir, here why the plus minus is actually we are taking?
So
As the graph is, plot is in the both side of the.
Both
yes.
sides.
So you have to, yeah, 0.9797, yeah.
Point 967 from 0.967.
967. Okay. Yeah. Months.
Sir, that means finally, actually in this question, the interval estimate means actually we are finding out the population mean basically.
Mean is actually one value, yeah. You can't find population.
No, the interval estimate will be the values from the, correct me, sir, if I am wrong, from the mean under the curve. That's why it is positive and negative, right?
So yeah, like you have, if you have this kind of plot, so which one is the mean? So the middle value will be the mean, yeah.
Middle value, yes.
So we are saying that what is the interval estimate that the 90% of the value will be there. So that's how. So it's plus minus, yeah.
1.62 and then respectively.
So
Like
you are
that
just
type.
seeing the spread of it, and yeah. Should we go ahead?
Yes,
Okay.
just a minute.
Please.
I'll just,
Anyway, I will just put. I think now the I have
okay, you can.
I have
Sir,
put the
just
PDFs now. I have started putting PDF. I have changed all the things to PDF. I think now it's now I think you if you have not checked, maybe check in the future. Maybe I think now the annotations are there. Yeah. Okay. Just maybe check afterwards. No issue. Just put everything in PDF now. The text size is okay, or should I increase it? Like, I don't know how to increase it. Huh?
Previous slide.
Okay,
yeah.
previous.
This is
Okay, just I will just show the previous
again
one.
it went back to original.
Yeah. Yeah, previous. If you want to capture it, yeah, but
Thank you, sir.
okay, okay.
Thank you.
Yeah.
I just want to take a picture of the previous slide. So please, sir, could you please
I will anyway put the PDF. Will it work actually?
Sir, will you upload this video
Yeah, yeah,
link in the Excel sheet also?
yeah, yeah. I will.
Okay, sir.
So yeah, like if it yeah, if it's okay, then I can. But anyway, I can also, once it is done, I can also show all the pages. That's not an issue.
Sir, can you please explain when the single one-tail test and two-tail test has to be done, sir? Does it depend on the variables or what is the criteria, sir?
Okay, I will. Yeah.
Based
So
on the number of samples.
yeah, I will anyway discuss the other tests, the chi and the t. So yeah, then we can.
So the first question answer is 23.97 to 17. That means 23 to 17.
The size of the sample, yeah.
Yes, sir.
How are you like kind of solving it?
Sir, but here precision is to be double means.
Okay, like the first one, how are you doing it?
Sir, we have given population variance, which is equal to 81 days. So we calculate standard deviation, and by putting all the values in Z formula, we get the average sample size, which is equal to, and the population mean is also given plus minus 3 days from that of the true mean.
Okay. So, okay, let's write what all we have. So we have we have x minus nu, which is plus minus 3. Okay, we have z, which is 2.33, yeah, because 98% confidence, and we have sigma, which is root 81. Yeah.
Yes, sir.
So we will put it in the formula that z equal to x minus nu by standard error. And we know standard error is sigma by root n. So we'll bring it here. So it will be 3 by 9 into root n. We know the value of z. Z is 2.33 root so n equal to 2.33 into yeah.
Yes, sir.
So what is coming?
.9, approximately 7, you can say.
Okay, 7. Okay, so it will be 49.
48.86.
48.88.
Yeah.
Means yes, 49.
49.
Such a square is there.
Yeah. So the sample should contain 49. So it's just a question, just to reverse. Yeah, mostly we will have the number of samples given, and then you have to study and tell the different the things that is asked, basically given, and some parts it will be asked there.
48.86. 48.86.
Yeah, like approximately you can have 49. So then you have to how large a sample would be required if the precision is to be doubled. So now I think yeah, so just I think I had shown it, but yeah, I think I have it in the slides.
So is it 196? If precision has to be doubled, should the sample size be multiplied by 4 times?
How? Which week it was? Let's see. I don't know in which one I think we'll have. Okay, so I think I haven't. So here the term is precision, yeah. So when precision is to be doubled, so when it is written that precision is to be doubled, so you have to decrease the this value, yeah, this x minus nu by that factor only. So this x minus nu is now 3. Okay, so as it is getting doubled, you have to divide it using that factor. So in a sense it is so it is the kind of a reverse of the spread, yeah. Your true spread is plus minus 3 days, but then you have to precise it, make it more precise. So how to make it more precise? We will decrease the spread more. So what we do is we will put it, we will divide it by 2. So what it will come as 1.5, yeah. Then upon putting it 1.5, what we have to do this whole calculation again, yeah. So this n, okay, what we will put, yeah. So here z z equal to x minus nu by standard error. So here so we have to again bring the value of n, yeah. So somebody told, yeah, n equal to what it was coming,
N equals to 40.86.
so it will be 2.33 into 9 by 1.5 whole square equal to n, yeah.
The answer is 7, around 7.
No, it won't come around 7.
196.
I don't know, let me calculate.
It is 196.
Yes, I think it's 195.5.
Okay, 14 square, yeah, it's around I think it's around 196, yeah.
Yeah.
So yeah, so it tells us that when we have to double the precision, so how the standard error or the number of samples increase, yeah. So how does the sample error how does the the with precision, how does it affect the sample error? Can you tell?
So since it depends on the n sample, this thing, and since we are taking the root of
Root
n,
of it.
if you have to double, then it has to be 4 times. So that when you take the root, it will be double again.
Yeah, like
So
it becomes
49
half.
into 4, which will give 196, and when taking the root, it will again come back to.
So the standard error becomes half. Yeah, it becomes half. Yeah, I think so, because it's in root and then it decreases.
In one of Sir's lectures, it was discussed. Sir was saying if the precision as required, it has to the sample number of samples should be 4 times, so that when you take the
Yeah,
square
yeah,
root,
yeah,
it will
yeah,
again.
yeah. The number of samples should be 4 times. So as it is in a root n, so it becomes half. That the standard error, I am telling. Like the change on the standard error with the number, yeah, it becomes 4 times. Okay. So yeah, any doubts here? Okay, then we can move ahead. Yeah.
Yes.
What are the two hypotheses? Like the null and the alternate hypothesis?
That there is no effect of lowering of plasma in the normal plasma tension levels in the normal males.
This is null.
Yeah, that is null.
Okay. Alternate hypothesis is?
There is the effect.
Okay.
So the null hypothesis that is given here, that males with a disease have lower potassium plasma level than normal males, that can be rejected.
Okay. So, okay, let's start solving it here then. So, what all we have? So, let's first define the two hypotheses. Null. H naught is what it is? Males with disease do not have lower plasma potassium, and HA is males with disease have lower plasma potassium. Yeah. And we have to be so we have population mean equal to 4.6. Yeah, this is the population mean. Yeah, predictor and sample mean also we have, which is 3.35. Standard deviation we have or not?
Sample size
and n is equal to 50. So okay. Standard error is
standard deviation divided by under root of n.
So it is coming out to be 0.0707.
0.0707. 0.0707. Yeah.
So okay, what will be here? The x.
Z is equal to x minus mu divided by standard error.
What is coming?
17.6.
Minus 17.85.
Okay. Anyway, the sign doesn't matter anyway. Okay, this one is coming. So okay, what's the value of z? Okay, the table value it's given, yeah.
Table value is given, sir, 2.58.
Okay, so we see that calculated value is greater than the table value, so we can reject the null hypothesis, and we can conclude that males with the disease have lower lower plasma potassium levels than the normal males. Yeah.
Excuse me, sir.
Yeah, please.
While considering the hypothesis, like the null hypothesis that you have considered, that they do not have any lower plasma potassium level, and this alternate hypothesis you have taken it as they do have a lower potassium plasma level, right? Can't we reverse this? Like I have considered while solving the null hypothesis as the male with the disease have a plasma potassium level lower than normal male, and my alternative hypothesis that it do not have the effect.
Yeah. Anybody would like to answer this?
So I think it depends on what we are trying to do, what experiment we are trying to do. So once if we are trying to prove that the diseased persons will have a lower, then that should not be the null hypothesis. Null hypothesis will be opposite what we are trying to do, what we are trying to prove. So it will be like they won't have any change.
Okay. Anybody else? So it's like on the definition, yeah. So null hypothesis means that the effect does not occur, yeah. That there is no effect there. That's what is null hypothesis. While in alternative hypothesis is that the effect occurs. So it's like that's why like it's made in a way, it's defined in a way that like it's kind of a definition, yeah. So you can't change it.
Here the null hypothesis is rejected, no, because we are getting
Yeah. No, like I was discussing whether we can reverse the hypothesis names and all. So like it is defined in a way that it's like that.
But here null hypothesis will be there, will be
it is rejected, yeah.
on lowering the plasma levels, right? Plasma potassium. So always null hypothesis is like there is no effect, like.
Sir, what I understood from the SARS lecture that in somewhat dependent cases are considered as H1. I mean, which has some effect on dependent something on that, and the H null should be that is the independent case. So is it correct, sir?
Yeah,
I
like
mean,
there
if
is no connection with the effect. That's what it is
yes,
the null.
there
And
is no relation, then H1 should be, that means they are connected somehow,
yeah,
and
like
H
H,
not
you
not.
can write H1, like I have written HA. Like, yeah, it's just on the notation here.
No connection between variables as far as the null hypothesis is concerned.
Yeah, that's how it is kind of defined. So we can't like directly change. So null hypothesis is
Rejected.
the H naught is rejected here.
The value of Z at 2.58 was much lower.
Yeah. So okay, we will go ahead.
It's around 0.9951.
I think you had this kind of question, yeah, in one of the vaccine question kind of, yeah. I thought, okay,
Yeah.
let's make something like this. So, just one clarification.
So this is a chi-square question.
No, this is Z only, but I thought, okay, let's give it.
Okay. Yeah, I was confused because I couldn't. Acha, this is the p value.
So this is the standard error you have to make. Okay. So let's see here. Just a clarification. Yeah.
So can you explain the question?
Okay. So, a total of 200 patients suffering from toothaches were divided into two groups. So, we have two groups here, 120 and 80. The first group is received drug A, the second group received drug B. The efficacy was measured by reduction in pain after the drug intake. Drug A failed in 36 cases and drug B failed in 16 cases. So we have to find the standard error between the failure rates and what inference is drawn. So, we can say that in 36 cases, like drug A failed in 36 cases and rest of the cases it passed, yeah. And similarly for drug B also, that in 16 cases it failed, but in the rest of the cases it was kind of a success. So then we have to approach it. So we have two groups and then we have to find the standard error of it. So when we have two groups, just to recall how we used to find the standard error there.
That is square root of standard deviation divided by number of population of group A plus the square of the standard deviation divided by number of population of group B.
Correct, yeah. So that way you can go ahead and maybe come with the standard error of the total system. So that's the first part of it.
Sir, is the answer for standard error is 3.74?
I actually don't know. Maybe we can try solving it. I don't have it. So the first population P1 is for, like, I'm taking P1 as drug A. So in this, number of failed cases is 36 and the probability will be 120, yeah. It is coming around 12.3 10. Yeah, so now we have to find the standard error of both the things. So for that we will take 0.3 minus 1 minus 0.3 divided by number is 120 plus 0.2 1 minus 0.2. Yeah, this formula you remember, yeah.
0.061.
Rest of it I can't solve actually. I don't have calculator. What is coming?
0.061.
0.061. Okay. Okay. So now we have to tell whether there is a difference in the failure rates between the two drugs. Okay. So we can just put this in the value in the formula, yeah, x minus, not that, x minus 1. We'll just take p1 minus p2 and standard error. So it will be 0.3 minus 0.2. Standard error is 0.61. Yeah.
Correct. 1.639.
9. 1.6329, I think.
1.639.
Is it?
Yeah, just 0.1 divided by 0.061.
2.639.
639.
1.639.
Okay. So what inference can be for? You all can refer to Z value 95% is okay. Yeah. 95% is how much? Z?
Yeah.
1.96.
1.96.
Yes.
1.62. No,
1.96.
1.96.
Okay. So we can say that okay. So first, so the what will be the null and hypothesis? We haven't defined actually. So the null hypothesis will be
Drug A is not failing.
no. We have to find the relation between the drug.
Okay.
So there is no difference between drug A and drug B.
That will be this one, alternative hypothesis. Yeah. Or what?
There is a difference.
So null hypothesis we have right now there is no significant difference between the mean values of an alternate hypothesis we write as
So here, in this case, why can't we take the null hypothesis as there is no relation between drug A and drug B, an alternative as there is a significant relation between A and B?
the same
Because usually we do that way, so why it is opposite to that?
because here what we are testing is effectiveness of drug A and drug B.
Mm-hmm. But the question is kind of what is the relation on the like whether the failure rates are same for both the drugs. So which one should go for alternative and which one should go for null?
Like as said, sir, just in a previous question when I asked about the null hypothesis and this alternative. So a null hypothesis should be concerned with a no connection with any specific effect, right? So if we take that into consideration, then there should be no effect of drug. I mean, there should be no difference between the effects of drug A and drug B as a null hypothesis.
So one doubt, sir. Should we consider two null hypotheses and alternate for each drug? So for drug A, there is one null and one alternative, and drug B also the same thing, and we'll have to find out the difference.
But then what are the...
Both are clubbed, I don't know how, sir. I think it
no,
must be,
that...
just clarify.
Yeah. Yeah. True. In a sense, like it says that it does not have any, like, from the result, as it is less than the
So it
table.
is rejected actually. Null hypothesis will be rejected, right?
No, null hypothesis should be accepted in this case, yeah, because the calculated value should have been if
greater than z.
Yeah, in that cases null hypothesis is rejected.
Yeah.
But in this case, null hypothesis is accepted. That is, there is no difference in the...
Yeah, there is no difference between both P1 and P2.
Yeah. I don't know. See, in some, I don't know. I think I have to read about it. But in cases where we compare two groups like this, like here we are comparing two groups here. In such conditions, this kind of questions arise. In essence, what would be the null hypothesis? And because in the last question, what we were saying, it's only we were comparing it with the table value, yeah. The sample and the population mean, yeah. In such conditions, the thing is, I think it stands. But here also, in a way, I'm not able to understand myself also. But yeah, like that's what it is, I think.
So here, suppose drug A was given to two groups, and then different groups, say children and adults. Then if you could have clubbed, I think it would make some sense. So this is entirely two different groups and two different drugs.
Yeah.
Whatever you are saying is, if it is to be distributed or given to two different age groups, those cases that will be mentioned in the question itself in order to make two hypotheses for drug A and two hypotheses for drug B. So that kind of situation, it must be given in a question itself. Here, it is not that scenario. So.
Okay, maybe I'll look upon it. I don't know. I am also not clear. But in a sense, it is different from the last question in a way that in the last question, we are comparing it with the population and the sample, yeah. But here, both the things are sample and we are comparing from it. So the two questions we can't...
here also we are comparing between the failure rates. Drug
yeah,
A and drug
that's what it is. But here, that was a case of, like, we already have a population and we are comparing it with our sample. Yeah. But here it is, both are samples. And then we are comparing the relation between them. So I think in such cases, maybe you all also maybe can try. I am also not maybe clear here. So, I will see this, no issue. But in a sense, it is solved like this. I think, yeah. But in a case, for now, I think we have in this the final is like null hypothesis is accepted. Yeah, and there is no no difference in failure rates. Okay, so there is no difference in the failure rates of both the drugs. That's what it is. So yeah, one of you were asking on, we have some time, but yeah, we can discuss on box whisker, maybe something. So we can have a data set and you all can start.
Excuse me, sir.
Please.
It's a question regarding to pretest also. I think as per I know that if the sample size is less than 25, then we have to apply pretest, right?
Then we have to
apply pretest formula.
Yeah.
That is quite different from the Z test.
Sir, please can you show the previous slide?
Actually, now I can't go back because this then will go back. This then will go.
Okay, no problem.
Once we finish this, we just so one of you just asked about box whisker, so I thought, okay, let's put something. So you have to put the box and whisker plot of it, and yeah, so anyway, you all can't show it, so okay, I can make it here, so no issue. So you have to make a box and whisker plot. So the first step will be to
arrange in order.
Yeah, so arrange. Yeah.
First of all, we have to arrange in ascending order. Ascending order, we have to put this data in ascending order. So it will be 10.1, then 15.0, then 15.3, then 15.9, 16.3, 16.7, then 17.2, then 17.9, then 18.2, then 18.3, then 19.1, then 19.3, then 20.2. And this all data, in total are 13 data points. So it is odd number. So the seventh one data point is a median. So it will be 17.2 is the median.
So it is what quartile?
17.2 will be the median.
Yeah. So which one it is? Like Q2, Q1?
Seventh one. It's like
No,
odd
like-
one. 1, 2, 3.
So we have Q2.
Q2, Q2.
Okay.
It will be Q2.
Q2.
Hmm?
Q2. It will be Q2. Q1 is 15.6.
This is 17.2. Yeah.
17.
17.2. And Q1 will be the mean of the third and fourth entire. So we will get Q1 15.6.
Third and the fourth one.
Yeah. So Q1 will be 15.6.
15.7.
How did you calculate the Q1?
15.7.
Q1 will be 15.6 and Q3 mean of the 10th and 11th.
How did you calculate Q1?
It will be in 15 and in between 15 and 16. So like while calculating it, so third and the fourth entire. So we will get 15.6.
So you are saying this one is Q2. Yeah.
Yes.
And then
Q1 will be 15.6.
okay. So you have 6 values above it. Yeah.
Yeah. And Q3 will be 18.7. It will be 10 and 18.7.
So actually this question, excuse me.
Yeah. Please.
Hello.
Yeah. Please.
Q2 13.7.
Actually, this question was already discussed by Sir in the main lecture. I have this notes, and my question in this was like we have certain outliers, right, in a box and whisker plots. So in order to calculate the mean, right?
Yeah. Mean. Yeah.
Yes. So in order to calculate the mean, do we neglect those outliers or we include those outliers? Because there was a question in assignment. There was a yes, there was one question. So in that I was confused a bit. Like if we have to calculate the mean, then we have to exclude the outliers and then we have to calculate the mean, or including the outliers we have to calculate the mean.
So the thing is, it comes. Sometimes it also depends on the flow of the question. Yeah. So if they are asking, if they are asking that portion before you are constructing the box and whisker plot, in such conditions you have to tell the mean from the whole data.
But sir, that thing was not mentioned in the question which is given in the assignment.
Okay. So otherwise it will have a sequential flow. Yeah. That this is asked first and this is asked then second. Is it like that? So it's like if you are constructing the box whisker plot and then asking it, in such conditions I think you have to remove the outliers. And if you are asking it just in a case before constructing the box and whisker plot, then you have to include it.
Okay, so I'll refer to the question once again, which is given in the assignment, and in next class, if possible, I can have a
it's possible
discussion on it.
Sure. So yeah, just we will complete it then. So Q1 is what I got lost actually.
15.6.
It is the average of these two. Yeah.
Yes.
15.6.
6. And
And
Q3 will be 18.7.
Average of which one?
18 Q3 average of 10th and 11th.
This two?
10th and 11th.
18.7.
Okay. It will be
19.1 and it will be 18.7.
7.
so we will have a plot kind of 10.
Q1, so we will get 3.1.
Oh, it's gone now. First value is 10.1, yeah. And Q1 is 15.6, yeah, I think so.
Yes, sir.
7. And this one is 17.2. So any outliers here?
So I think the minimum one will be an outlier. Sir.
What is the interquartile range?
3.1.
3.1, sir.
15.7 minus
15.6. So it will be 3.1.
So 1.5 IQR.
$4.65.
Huh? This is
4.65, sir.
Okay. So if we go less than this, how much it comes?
So Q1 minus 4.65 will be 6.75.
Q1
minus 4.65. That will be 6.75, which is less than the minimum.
Okay, so we are safe on this, yeah?
And for Q3, 18.7 plus 4.65 will be 20.2, which lies within the 23.35, which is again, which is outside the maximum.
How much it is coming?
So 18.7, Q3 18.7 plus 4.65 is 23.35.
Okay.
That is more than the maximum.
Okay. So we do have any outlier or not?
Q1 will be outlier.
How?
Sorry, minimum will be outliers. 10.1 will be an outlier.
What is the limit?
No outlier there.
20.2, I think. So you can. No outliners, sir. On the higher
Is
side.
it? No outlier?
Yes, sir.
The thing is, do one more. Yeah. So yeah, that's all. Maybe next session we will I'll bring some another questions on chi-square or t-test maybe. Yeah.
7, we wanted the explanation of the t value, sir, how to find the p given the t value. There's some confusion with that. Last class there was one discussion. So the value was not the. If suppose the t value is given as 0.559, how, what will be the p value for that, sir? Using the t table.
Okay, maybe yeah. Because anyway, next session we will be talking on only on chi and t. That time we can. But in a way, you have to also tell the degree of freedom, yeah. Then only we can.
Degree of freedom was given. Degree of freedom was 19 in this case. But I don't know how the t value is given as 0.559 and they were asking for p probability value.
Okay. Anyway, we can see it.
Excuse me, sir.
Yeah, please.
Sir, in this problem, if we want